Here's a couple of trig identity questions. I guess it's manipulating trigonometric expressions, but we might use some identities. So I've got three questions. So this first one, they actually ask you to factor this as opposed to using an identity. When you look at it, question number 13 here, it looks a little bit strange because you've got a cos squared and a cos, but this is very similar to this question. And what we're asked to do is factor that. So lots of people factor that using guess and check. You can also use the AC method to factor that. So this trig one is the same thing. So like I do the guess and check. So 2x squared I split into a 2x and an x. And then 3 I can split into 1 and a 3. And it's just guessing where if the 1 goes there or the 3 goes there. Same thing with the trig one. So I'd have 2 cos x here and cos x there, and then I have to figure out where that 3 goes. I think the 3 goes here, and the 1 goes there, and then probably this one's plus and this one's minus. I'm not sure, but this is where the check would come in. So 2 cos times cos would be 2 cos squared x. 2 cos times negative 1 would be a negative 2 cos x. 3 times cos x is a positive 3 cos x, and 3 times a negative 1 is a negative 3. I know for sure I get the first and last term because I rigged it that way, but this middle term, when I add them, so negative 2 plus 3 is a positive cos x, then I check to see at the top, sure enough that's what they have. So this here is my factorization of that. Okay, so you can do factoring with trig stuff too. It'd be cool if that question was 2 cos squared x plus cos x minus 3 equals 0, and you were asked to solve that. That'd be a good question. And what you do at that point, if it were an equation, and they don't want it for this question, but if they were, then you take those things that was factored, 2 cos x plus 3 and cos x minus 1, and set them equal to 0. So you'd have 2 cos x plus 3 equals 0, or cos x minus 1 equals 0, and then you'd solve each one of those equations. They didn't want you to do that for this question, though. All they wanted was the factor. Here's another question. Whoops. Here's another question where they're asking you to simplify this trig expression. And to simplify, you do similar things as if, like if you wanted to think of the cos as being x and the sine as being y, you could do that kind of thing. At any rate, with this one, if you're trying to simplify any rational kind of expression, you want to factor everything. So I've got 2 cos over sine squared times. Now here, I think I can factor that. I think I can factor a sine out, and I'd be left with sine minus cos. And then on the bottom, this is a difference of squares. It's just like x squared minus 9, where you get x minus 3, x plus 3. Same thing there. So it'd be a sine minus cos and a sine plus cos. Now you look to see if you can cancel things. So here's a sine minus cos, there's a sine minus cos. Here's one sine at the top, and there's 2 of them at the bottom, so I'll cancel one of them out. So left with up top, I'd have 5 cos, and on the bottom, looks like I have a sine, and then a sine plus cos. Whoops. And I'd probably leave it like that. I guess you could multiply, distribute that through, but I'd probably just leave it just like that. All right, and now here's a question dealing with identities. This one they say, what is the sine of pi over 12? Well, first thing, this is an angle in radian measure. So if I look at a quadrant, if they're splitting 12, so they're splitting this 180 degrees into 12 sections. That's a whole lot of sections. But I sort of have a hard time figuring out this in radians. So often it's not a bad idea to change that to degrees just to get a better handle on what it is. So you can times that by 180 over pi. That's our quick way to change to degrees. Pi's cancel. 12 goes into 80, I think 15 times. So sine of pi over 12 is the same thing as the sine of 15 degrees. Now here's where I can start saying, well, 15 degrees, and they want the exact value of this. So I can't just type on my calculator sine 15 gives me point something. Can't do that if they want the exact value. But I do have these sum and difference identities that I can use. And so they say the sine of the difference of two angles, u minus v, is all you have to do is take sine u and cos v, and then minus. You always take that. If you're doing minus here, you take minus on this side. Cos u sine v. So 15, if I remember my table, I have sine, cos, and tan, and I have 30, 45, and 60. What I can do is, since I'm taking the sine of a couple of angles, I can use these angles to see if I can get 15. So what combination of those two angles can I use? I won't be adding them, probably subtracting. What combination can I use to get 15? Well, to get 15, you could go 45 minus 30. You see where we're heading there? So now I can use this identity to help me figure out what that's going to be. So 45 is like u, and 30 is like v. So if I follow this identity, I can say, well, that's the same thing as sine of 45 cos of 30. And then again, since it's minus, I'm using the bottom sign there, minus cos u, so that's cos 45, and sine 30. And now all I do is from my chart figure out what each one of those things are, and I put it right down below. So sine 45 is root 2 over 2. So this thing becomes root 2 over 2. Cos 30, that's this one. That's root 3 over 2. So root 3 over 2. Minus cos 45, that was root 2 over 2 again. Root 2 over 2. And sine of 30 is 1/2. 1/2. Okay, multiply root 2 times root 3 is root 6 over 4 minus root 2 over 4. And you could probably leave it like that, but since they have a common denominator, might as well collect them. So it'd be root 6 minus root 2 all over 4. That's probably where I'd leave my answer for that one. Alright, hopefully that helps you with a couple of questions related to identities.